G'day guys, a student of mine has given me a relatively interesting calculus question from a practice exam that he's been given. So we've got two curves, y equals a times the square root of x and y equals ax squared, and they intersect at the point 1, a. We've got that on this little picture here as shown. Determine the value of a which makes the shaded area equal 1 for 0 to x to 4. So this shaded area here has to equal 1. Now the way that we're going to do this is we're going to break down the integration into two parts. We're going to do, the first part is going to be between 0 and 1 where the two curves intersect. So let me just try and draw a nice straight line going down there. Close enough. So this is going to be our first integral. And our second integral is going to be this larger shape here. Now when added, these two integrals have to obviously equal 1. So let's go about doing this. So what we've got here is we're going to be integrating from 0 to 1. Let's start with writing that. So we're going to be going the integral of 0 to 1 of, now the first curve we're going to be integrating against is this ax squared. So this is the integral of 0 to 1 to ax squared. Now dx. Now to that, what we're going to do is we're going to add the integral from 1 to 4 of a times the square root of x. Cool, and after we've done that, we have to equate this to being equal to 1. Okay, so what we're going to do, guys, is we're going to integrate both of these with respect to x. And for the first one, it's relatively straightforward. What we're going to have is, let's put our square brackets in. So we raise the power by 1, we've got x cubed, so it's going to be ax cubed divided by 3. And that has to be evaluated between 0 and 1. And to that, what we're going to do is we're going to add, let's put our next square bracket, the integral of this. Now, if you guys are still like working on your integration, we can write a times the square root of x as ax to the power of a half. So what we're going to do is when we raise the power of this, so if we're going to integrate this, if we raise the power of the x by 1, we're going to get ax to the power of 3 over 2. And to make sure that when we times that down, when we differentiate and we get just a coefficient of 1 out the front, we're going to times this by the reciprocal of this new power here, which is 2 over 3. So this is going to be 2ax to the 3 over 2 over 3. Cool, so let's put that into our square bracket. So we have 2ax to the 3 on 2 all divided by 3, and that's got to be evaluated between 1 and 4. Now after that's all said and done, it's got to be equal to 1. Now just a bit of a FYI for anyone who's looking at this going, oh, I could do this in my calculator. This was in the calculator free part of the practice exam, so this would have to be done without any kind of electronic help. So what we're going to do next, guys, is we're actually going to evaluate these integrals here. So let's go about doing that. I'm just going to change color. So I'm going to substitute in my 1. So we have a times 1 to the power of 3, which is just a over 3. So the first one, we have a over 3. And that would be minus, if we put a 0 in here, we're just going to have 0 over 3, which is just nothing. So we're going to leave off the 0. So we have a over 3 plus. Now let's put a bracket. Let's substitute in 4. Now I'm looking at this fractional power here, and I've got a feeling that if rather than substituting in 4, I'm going to substitute in 2 squared. Now you might be going, what the hell is the difference? Well, if you're not using a calculator, this will make all the difference for your mental maths. So this is going to be 2a, rather than writing 4, I'm going to write 2 squared to the power of 3 on 2. All divided by 3. Now we're going to minus. We put in a 1, so we have 2a, 1 to the 3 over 2, so that's just 1. So we have 2a on 3. Now let's evaluate this fraction. So we're still going to have our a over 3 plus. Now this one here, when we put our indices into a bracket, we multiply the powers together. So 2 times 3 over 2 is 6 over 2, or just 3. 2 to the power of 3 is 8. So this is going to be 2a multiplied by 8 over 3. Then we've got minus 2a on 3. Now, just for if you guys missed what I just did then, let me just rewind a little bit. We've got, so 2 squared to the power of 3 over 2 is going to be equal to 2 to the power of 2 times 3 over 2. So we multiply into the bracket. So 2 times 3 is equal to 6. Well, this is equal to 2 to the power of 6 over 2. 6 over 2 is equal to 2 to the power of 3, which is equal to 8. Cool, so that's how I got this 8 here, guys. So then what I'm going to do is finally, and this has all got to equal 1. And I think that one there has to equal 1 as well. So what we're going to do is we're going to evaluate 2a times 8, or 16a. So we have a plus 16a minus 2a, all divided by 3 equals 1. Now from here, what we're going to have is a plus 16a is 17a, minus 2a is 15a on 3. So therefore a is going to be equal to 3 on 15, or if we simplify it, a is going to be equal to 1 on 5. Cool. So this is a 4-mark question, guys. If I didn't have to explain like every single step to you, I don't think it would have taken me too long to go from beginning to end. However, there are a few steps which you could make a mistake on. What I would do is, in this one, I first of all broke my integral down into 2 parts. So I knew that I had to integrate from 0 to 1 and from 1 to 4. Once I'd done that, I evaluated each of my integrals on those boundaries. And then finally, I did a little bit of algebra and came up with my answer. It's not a very complicated question if you know the steps, but under exam conditions, knowing the steps, sometimes you'll just lose your way a little bit. But I guess with practice, if you practice with questions like this, in an exam, they'll be kind of second nature. So I hope the video helped, guys. If it did, definitely leave a thumbs up. It does help my channel. If you also would like to subscribe, I put out new videos almost every single day of the week. And finally, guys, if you have any problems with this video, or if you've got any questions which you would like to ask me about any future videos that I could do, please don't hesitate to leave them in the comments section below. But until then, guys, just make sure if you are struggling a little bit, just take heed. If you practice, keep banging your head against the wall. Eventually the wall will fall down. But just keep making sure you're enjoying your maths. It is just a game anyway. So have fun, and I'll see you again here next time.